when a is nearly equal to 2, then the value of L, that is the function, is nearly equal to 4. That is the meaning of x tends to a. The value of f of x will remain minus 1. So as x approaches from the left of the 0, then the value of the function f of x will remain minus 1. Check whether they are equal or not. What is left hand limit? Minus 2, and this is plus 2. They are not equal. So that means what we say, therefore f of x is not defined. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, faculty department of mathematics, Vidhyaashram PU College, the Temple of Excellence. Today in this session I am going to discuss very important chapter, that is limits and derivative. This very important chapter, you may expect around 10 or 12 marks from this chapter. So one definite question from limits. So today we are going to discuss regarding the introduction for limits, and that is the definition and verifying the continuity of a function, finding the left hand limit, right hand limit, and the functional value. Now, so here in this chapter, so for limits you are going to get one 5 marks question. So we have two theorems. So we are going to get either first theorem or second theorem derivation for 5 marks, and one MCQ question from this. So now let us move on to the concepts today. Now let us know what is the definition of a limit of a function. Now what is the meaning of a limit x tends to a? What is the meaning of x tends to a? Let x be a variable and a be a constant. Since x is a variable, we can change its value. It can change so that its value comes nearer and nearer to a. Then we say that x will approach us to a value, and it is denoted as x tends to a. Say for example, when a is nearly a is equal to 1.9, 1.99, 1.999, that means this is nearly approaches to a value. We can say here, so we can say that the value will nearly approaches to 2. When x will approaches to a value, that is f of x will approaches to a value nearly equal to 4.01, 4.001 or 4.0001, etc., then we can say the value of x will approaches to 4. So that is the meaning of x tends to a. That means let x be a variable and a be a constant. Since x is a variable, we can change its values. It can be changed so that its value comes nearer and nearer to a. Then we say that x will approach us to a, and it is denoted as x tends to a. So here this value of f of x is called as L. That is called the limit of a function. So the value of f of x is nearly equal to 4 when a is nearly equal to 2. That means when a is nearly equal to 2, then the value of L, that is the function, is nearly equal to 4. That is the meaning of x tends to a. Now let us investigate the behavior of the function. Now f of x is equal to x square minus 4 divided by x minus 2 at the point x is equal to 2 and nearer the point x is equal to 2. X is equal to 2 as well as at the point which is very nearly equal to 2. Now as such, if you take f of x is equal to x square minus 4 by x minus 2, by putting x is equal to 2, what we will get? So this is nothing but 0 by 0 form. We are going to get an indeterminate form. So therefore this can be written as f of x is equal to x plus 2 into x minus 2 divided by x minus 2. This is of the form a square minus b square is a plus b into a minus b. So x minus 2 gets cancelled. F of x is equal to x plus 2. So if you put x is equal to 2, f of 2 is equal to 2 plus 2 is equal to 4. So f of 2 is equal to 4. Now what is say? At the point x is equal to 2, it is nothing but 0 by 0, which is not defined. X is nearly equal to 2. When x is nearly equal to 2, we will get the functional value is equal to 4, right? So that means when x is equal to 2, f of x, the function is not defined. This is not defined. We will not define, not defined at x is equal to 2. Now x is nearly equal to 2 means either x is less than 2 or x is greater than 2. So in this case, f of x is equal to, that is f of x is nearly equal to 4, which is defined. So at x is nearly equal to 2, the functional value of x is defined in this case, right? So that means at x is equal to 2, f of x is not defined. At x is not equal to 2, then f of x is defined. Now move on to the next concept. Now let us, by knowing this, let us know regarding the definition of a limit. Now let f of x is a function defined on an interval that contains x is equal to a except possible at x is equal to a. Now let us consider a function. Let f of x is a function defined on an interval that contains x is equal to a except possible at x is equal to a. Then we say that limit extends to a of f of x is equal to L. So limit extends to a of f of x is equal to L. That means in general, as x tends to a, f of x minus L, f of x tends to L, f of x will tends to L, then L is called the limit of the function f of x, which is symbolically represented as limit extends to a of f of x is equal to L. Now, how to define the limit of a function? Now, that means the limit of a function is defined as limit f of x of a function is defined in an interval that contains x is equal to except that it contains x is equal to a except the possible at x is equal to a, and we denote it as limit extends to a of f of x is equal to L. Now discuss the limit of the function. So to discuss the limit of a function, check whether the left hand limit as well as the right hand limit are equal or not. If they are equal, then we can say that the limit of this function exists, otherwise does not exist. Now let us verify the left hand limit and the right hand limit. Just by seeing to the problem, we can say that the left hand limit is -1 and the right hand limit is +1. We can say that the limit of this function does not exist. Now let us verify this. Now when x is less than 0, what is given? F of x is equal to -1. So let us find out the left hand limit. Left hand limit is limit extends to a minus f of x. So here this is limit extends to 0 minus, what is f of x? F of x is equal to -1. So we can write left hand limit is equal to -1. On the other hand, when x is greater than 0, f of x is given, that's equal to +1. We can write right hand limit is equal to limit extends to a plus f of x. So that's equal to limit extends to 0 plus f of x. F of x is 1, that's equal to 1. So right hand limit is equal to 1. Now what do you say from these two? So left hand limit is equal to right hand limit. What is left hand limit? -1. What is right hand limit? +1. Are they equal? They are not equal. So they are not equal. So therefore limit of this function, limit of this function does not exist. Does not exist. That's it. So left hand limit and right hand limit are not equal. The limit of this function does not exist. Okay. Suppose if you draw the graph for this. So let us write the graph x axis and y axis 0. So this is +1 and -1. Okay. So at x is equal to -1, we have this is 0 and this is -1. Okay. Now here, as x approaches to 0 from left of the 0, see, as this x approaches from the left of the 0, then the value of f of x will remain -1. So as x approaches from the left of the 0, then the value of the function f of x will remain -1. Similarly, then we say that the left hand limit of the function is f of x is -1. Okay. This is how we are going to discuss the limit of the function. Now move on to the next problem. Discuss the limit of the function f of x is equal to x plus 10 at x is equal to 5. Okay. Now what is given here? F of x is equal to x plus 10 and x is equal to 5. Right. Now let us find out the left hand limit. Left hand limit. For left hand limit, let us take the value of x is equal to, let us take x is equal to the values which are very nearly equal to 5. That is, let us take x is equal to 4.9, 4.99, 4.999, etc. Then what happens? F of x is equal to f of x is equal to x plus 10. X plus 10 means then this when x is equal to 4.9, so 4.9 will get 4.9 plus 10, that is nothing but 14.9. So f of x will approach us to the values. First one is 14.9. When x is equal to function of 4.99, we will get 4.99 plus 10, that's equal to 14.99, comma 14.99. Similarly, f of 4.999 is equal to 14.999. So this is 14.999 and so on. Okay. Now what do you say? As x approaches to a value nearly equal to 5, when x tends to 5, f of x, that's equal to L, will tends to a value which is nearly equal to 50. That is the left hand limit. Now let us take the right hand limit. For right hand limit of a function, f of x is x plus 10. Okay, that is x plus 10. Now for right hand limit, let us take the value of x is equal to 5, comma 5.1, comma 5.11, etc. Let me start with, now let us start with x is equal to 5.1, 5.1. Next 5.01. Okay, 5.1, 5.01, then 5.001, etc. Then what happens to this f of x? F of x is equal to 5.1 plus 10 is equal to 15.1. And f of x, this is f of x at 5.1. Similarly, at 5.01, 5.01 plus 10 is equal to 15.01. So f of 5.001 is equal to 5.001 plus 10, that's equal to 15.001. Okay, and so on. So what do you say from this? When x approaches to a value 5, this f of x, nothing but L, will approach us to a value which is nearly equal to 15. So we can say that the right hand limit is equal to 15. So in the previous case, the left hand limit is equal to, here the left hand limit is also equal to 15, and here right hand limit is also equal to 15. So since left hand limit is equal to right hand limit, that is 15 is equal to 50. So therefore what do you say that? Therefore the limit x tends to 5 of f of x is equal to L exists. That means therefore the limit x tends to 5 of x plus 10 is equal to 15. The limit of this function is 15. Okay. Now move on to the next problem. Same, discuss the limit of the function f of x is equal to x cube at x is equal to 1. Same type problem. Now, so let us take the left hand limit. Left hand is limit x tends to 1 minus f of x, that's equal to limit x tends to 1 minus f of x is x cube. So that's nothing but 1 cube is equal to 1. So left hand limit of this function is 1. Similarly, right hand limit is equal to limit x tends to 1 minus f of x, that's equal to limit x tends to 1 minus, what is f of x is x cube. So that's equal to 1 cube is equal to 1. Right hand limit is also equal to 1. Left hand limit and right hand limit are equal. So therefore the limit of this function exists. So since left hand limit is equal to right hand limit is equal to 1, so therefore limit x tends to 1 of f of x is equal to 1 exists. So the limit of this function exists. That's it. Okay. Now move on to the next problem. So this is how we are going to discuss the limit of this function. Let us take one more example. Suppose if left hand limit and right hand limit are not equal, in that case the limit does not exist. Now let us take one more example for this. Now let us take, for example, if f of x is equal to, f of x is defined by x minus 2 when x is less than 0, equal to 0 when x is equal to 0, and x plus 2 when x is greater than 0, right? So in this case, find the value of this limit. Find the value of limit. Find at x is equal to 0. Find the value of limit at x is equal to 0 or discuss the limit of this function. Now here what is given? When x is less than 0, f of x is given. F of x is x minus 2. When x is equal to 0, f of x is equal to x minus 2. So therefore we are going to get the left hand limit. Left hand limit is limit x tends to 0 minus f of x. That's equal to limit x tends to 0 minus, what is f of x is x minus 2. Now put x is equal to 0. 0 minus 2 is minus 2. Similarly, on the other hand, when x is greater than 0, when x is greater than 0, what is given? F of x is equal to x plus 2. So we are going to get the right hand limit. So here in this case, the left hand limit is equal to minus 2. Left hand limit is minus 2. Now verify the right hand limit for this function. What is the definition? Limit x tends to a plus f of x. So that is nothing but limit x tends to 0 plus f of x is x plus 2. Now x is equal to 0 plus 2 is equal to 2. So the right hand limit of the function is 2. That means here the left hand limit is equal to right hand limit. Check whether they are equal or not. What is left hand limit? Minus 2 and this is plus 2. They are not equal. So that means what we say, therefore f of x is not defined. So limit does not exist. Not defined. Not defined. That means limit of this function does not exist. Of this function does not exist. So the limit of this function does not exist. Okay. So if you draw the graph for this, what is the graph you are going to get? See, this is the graph. Zero, 1, 2, 3, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 1, minus 2, minus 3, minus 4. Okay. So at x is equal to 0, the value left hand limit and right hand limit at x is equal to 0 are plus 2 and minus 2. So that means these are the values. So this is plus 2 and minus 2. Right. So what do you say? So therefore the limit of this function does not exist. So therefore limit does not exist for this function. So this is how we are going to verify whether the limit exists or not. So in general, if both the limits, if left hand limit and right hand limit are equal, then we are going to write if left hand limit is equal to right hand limit, then this is denoted as limit x tends to a of f of x is equal to L. That is called limit of a function. So the limit will exist. If left hand limit and right hand limit does not exist, then limit of the given function does not exist. So very simple concept. That's it. Okay. Now hope you followed regarding the definition of a limit and how to verify the limit of a given function. That's all regarding today's session. Let us meet with a different concept in the next session. Thank you. Thank you very much.